So the question says a geometric sequence has first term 3 and last term 8. A1 equals to 3 and AN equals to 48. If each term is twice the previous term, that is, let's have A1 which is 3. A2 is 3 times 2, previous term 6. Then A3, each term is 2 times the previous term, so A3 should be 2 times this one, so 6 times 2, 12. A4 should be 12 times 2, which is 24. So dots, 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 the last term, A5, dots, 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 which is 48. So the minute I know this, remember that AN of an arithmetic of a geometric progression, that is R is equals to 2. That's what this thing simply means. So remember that AN of an arithmetic of a geometric progression is AR raised to n minus 1. So that means that they say we should find the number of terms and the sum of the geometric progression. So that means that this is the sentence saying 48 is equals to 3 into 2 raised to power n minus 1. That's what it means. Find the number of terms and the sum of the terms. So we have to find n and then find Sn. We don't know, but we know the last term. Number of terms is n. Nth term or last term is given 48, but we don't know the number of terms. So this is going to be the sentence saying there's 3 here, 48. So this is the sentence saying divide both sides by 3. So 3 2 n minus 1 over 3, 48 over 3. This will cancel this. 16. So 16 is equals to 2 raised to power n minus 1. So 2 raised to power 4 is equals to 2n minus 1. Remember base law. If the bases are the same, the powers are equal. So 4 is equals to n minus 1. So n is simply equals to 1 crossing over 4, that is plus 1. N is equals to 5. So therefore, Sn will be equals to A into R n minus 1 over R minus 1. So we've gotten this to be 5. So that means that we'll now have, remember, we don't know the sum of the terms, so we'll just do Sn equals to 3 into 2 raised to the power 5 minus 1 over 2 minus 1. So 3, 2, 4, 8, 16, 32. 32 minus 1, don't come. So it's so much A. So 32 minus 1, this is all over 1. So this is equals to 3 into 31. Anything over 1. So, and that is the sentence saying is the 93. So the sum of the nth term is simply 93. So let's move to the next one. Question 16. If Naira 1 Naira is saved the first day, if 1 Naira is saved the first day, 2 Naira the second day, 3 Naira the third day, etc. Find the sum that all the savings will accumulate to at the end of 365 days. So it's the same thing as I've already made it. That is 1 Naira, 2 Naira, 3 Naira, in 365 days, you should have 365 naira. That is each day 1 naira, 2 naira, 3 naira. Is adding 1 every day. That is the common difference in that case. Common difference is 1. Find the sum that all the savings will accumulate to at the end of 365 days. So EN, the last term is 365, is there. I've told you that once you see this thing after dot dot dot, it means that EN is given. Then E1 is equals to 1 naira. Then the common difference D is equals to 1. So remember that EN is equals to E plus M minus 1 D. So was I given N number of terms? I received the first day, second day, third day. Find the sum of all the. So I'm not giving N number of terms. 25. So let me do 365 is equals to 1 plus M minus 1, then 1. This should be 1 plus, if 1 come here and times M minus 1 equals to 365. So I simply have 1 minus 1, 0 plus N equals to 365. So N is equals to 365 days. So it's 365. I don't have to call it days. I don't know. So number of days actually, or number savings. Now all the savings will accumulate. Find the sum that all the savings will accumulate at the end of it. So number of terms is 365. So remember that Sn is equals to N over 2 into E plus N, En. So I should have N over 2 equals to, and En is 365. Then E is 1 plus 365. So this is going to be the same thing as saying, let's make use of our calculator. So we have 182.5 into 366. So 182.5 times 366. So the sum of terms is going to be 66,795. That's the answer. Remember we said when it keeps adding. So since it's adding, the common difference is 1. So that's for question 16 we just solved. This is question 16. Why this one is number 15. So let's move to question 17. This 17 is easy. We've solved something like this before. So I'll be skipping questions now. We've solved something like this. So let's solve number 18. Find an expression for the nth term. I'll solve just 18a. 18a. We have En is equals to 2, 4, 6, 8, 10, dot, dot, dot. Then they said we should find an expression for the nth term. Then we find the next 2 terms of the sequence. So let's just do this. Let's check. This is E1, E2, E3, E4, E5. E2 minus E1 is equals to E3 minus E2. Should be? That is 4 minus 2 is equals to 6 minus 4 is equals to 2. Common difference. So remember that an is equals to a plus n minus 1d. So here we have 2. They didn't give us number of terms, but they say we should find an expression for the nth term. Question 18. So 2 plus n minus 1 into 2. 2 plus 2n minus 2. So this should be 2 minus 2 is 0. So an is just 2n. N is just 2n. So they say you should find the next two terms. The next two terms. So if we are to find the next two terms, remember it's I. Next two terms. Next two terms, instead of coming here to be doing n to be anything, because we don't know what this n actually is. The best thing to do, since they didn't give us dot, the best thing to do is simply to come here and say is an arithmetic progression. AP is that type of sequence where the first term plus the common difference gives you the second term, and the second term plus the common difference gives you the third term. So the next two terms, A3 plus D gives you A4. A4 plus D gives you A5. And we have A5 already. A5 plus D gives you A6, which is the next term. Then A6 plus D gives you A7. So what we need is A7 and A. So simply do 10 plus 2, which is 12. 12 plus 2, which is 14. So this is the next term. The next two terms. So the B, C, D, you can solve it the same way. Solve the same way. Using same steps. So let's move to number 19. Number 19. The nth term of a sequence. The nth term of a sequence is an equals to 4n minus 2, rather than the first 8 terms. So since 19, since the an is equals to 4n minus 2, all you just need to do is an is equals to 4 into first term minus 2. So the a1, sorry, a1 will be n becomes 1, so 4 into 4 times 1 is minus 2. So equals to 2. Even if you look here, that last question we did, I think something like this can work. If we say the sixth term here, let's say we said since an is 2n, if we say sixth term a6, we'll come and say 2 into 6, it will give us 12, which is this 12. If we say a7, which is 2 into 7, it will give us 14, which is this 14. So since this one they gave us this, so the first term will be this, second term a2 will be 4 into 2, n will become 2 minus 2, so 8 minus 2, 6. So that means they said write down the first 8 terms. That means the first 8 terms is 2, 6, 10, 14, 18, 22, 26, 30. So this is the first 8 terms: E1, E2, E1, E2, E3, E4, E5, E6, E7, E8. Let's move to the second part. They said, what is the 42nd term of the sequence? Wonderful. The 42nd term, that is II. 42nd term should be E42 equals to, remember they gave us 4n minus 2, so it will be 4 into 42 minus 2. One, let's do punching. 4 times 42, 168 minus 2, and that should give me 166. That's the 42nd term. Now I. They said, what term of the sequence is an equals to 42, is equals to 74? What term of the sequence is an equals to 74? So all I need to do is an here. First of all, is equals to 4n minus 2. So here an is 72 equals to 4n minus 2. So all I need to do in this case is to say, remember an here, they gave it to be 72, but an in this equation, in this sequence, is equals to 4n minus 2. So all I need to do is to say 72 minus 2 is equals to 4n. So that means that 70 is equals to 4n. 70 divided by 4. So divide both sides by 4. So n is equals to 17.5. Simple. So they said what term? So the term that's n. Okay, 74. Are you kidding me? 74. They said an is 74. I'm doing, oh God. So it's going to be 74 minus 2. So which is equals to 72. So 72 divided by 4 is 18. It's 18. It's 18. So n is 18. That means the 18th term is equals to 74. That's what it means. So see, I'll continue with this question. But there are questions I want to touch here. They said, show that log x plus log xy plus log xy square plus log xy cube is an arithmetic series. So let's show that. You remember that logarithm log ab is equals to log a plus log b, and then logarithm log a over b is equals to log a minus log b. And if they say log a square is equals to 2 log a, find the logarithm, then multiply it by 2. If you remember, these are rules of logarithm. So if I'm given, I also need to know that arithmetic sequence is that one that moves. Arithmetic sequence goes this way: A, comma, A, B, comma, C, comma, D. While arithmetic series is A plus B plus C plus D. So if I know this, I need to remember that according to AP, the first term of an arithmetic series is A, while the second term is A plus D. The third term is A plus 2D. The fourth term is A, third term is A plus 3D. The fourth term is A plus 3D. The fifth term is A plus 4D. First term, second term, third term, fourth term, fifth term, blah blah blah. So if it's serious, they are talking about, so you should prove by serious, it is going to be the same thing as saying put plus. Once you sum up a sequence, it becomes a series. So plus, this is an arithmetic series. So going by the question we have, log x is the first term. Log x is the first term, and log xy is the same thing as saying log x plus log y, and this should be the second term. And notice, if this is A, this is plus. Let's say this log y is D. And let's go again. They gave us log xy square. So log xy square is the same thing as saying log x plus log y square. And log y square is the same thing as saying 2 log y plus log x. Remember, this is A and this is D, so 2D. And this is our third term. Then they give us log xy cube. They want us to show that it's an arithmetic series. So log xy cube is the same thing as saying log x plus log y cube. And this is the same thing as saying 3 log y plus log x. Fourth term. So if you check it, if log y is D, it's carrying 3. This is A. So if you check it very well, see that this is now the same thing as saying A plus, and it corresponds to the setup A plus D, A plus 2D, A plus 3D. So log x, log xy, which is log x plus log y, then log x plus log times 2 log y, then log x plus 3 log y. So by the time you put it plus, see that is an arithmetic series. So hence proved. So proved. Oh yeah. Next question I want to look at. We don't have time. Next question I want to look at is the first term of a geometric sequence, question 40. First term of a geometric sequence is 3. E1 is 3. Last term En is 48. What is the common ratio if the sum of the n terms Sn is 93? So we are looking for R. So in this case, question 40. This one is question, remember this is question 34. I'm rushing it. So remember that this is GP they are talking about. So we have EN to be equals to ERN minus 1. And in this case, AN is 48 equals to 3E. Then R we don't know, N minus 1. Divide both sides by 3. And you get 48 over 3 equals to 3 over 3RN minus 1 over 3. This way, 16 equals to Rn minus 1. So you can now see that we don't know what this is, but we know that Rn raised to power minus R raised to power n minus 1 is the same thing as saying Rn over R, then 16 over 1. So this is 16R is equals to Rn. So Rn is equals to Rn, that is Rn is equals to 16R. So let's leave it at this. Then we are giving sum. We are given that the sum, I know that sum is the same thing as saying A into Rn minus 1 all over R minus 1. So A is 3. Rn already is equals to 16R minus 1 all over R minus 1. Then Sn is 93. Is given. Sn is 93. Remember, this is the question. Sn is 93. So it's given. So all we need to do is over 1 cross multiply. So this becomes 93 into R minus 1 equals to 3 into 16R minus 1. Are you okay? Oh yeah. So this will be the same thing as saying 48R minus 3. And this is the same thing as saying 93R minus 93. Collect like things. 93R minus 48R is equals to minus 3 plus 93 equals to 90. Then 93 minus 48, 45R. To get R, divide both sides by 45. R is equals to 2. Very simple. Very simple.